that we can just replay our program. And Mr. Harfouche, what do you think if we will start with you? Are you ready?
I'm always ready. So if you want, we can start with me.
Okay, but let me introduce you to our participants. Dr. Antoine Harfouche is an associate professor of information systems and artificial intelligence at the University Paris Nanterre, and he will have a report on the topic new research design and methodology to analyze the impact of artificial intelligence on management. So, Dr. Antoine, please be welcome.
Thank you very much for this introduction. I will share my screen if it's possible. Oh, it is possible. Can you see my screen? It seems it's possible.
Yes, yes, we can see your screen.
Perfect. So yes, thank you for this introduction again. As you said, the idea is to discuss with you the implications and future implications of this new research stream that we are starting, which is the AI, research in AI, artificial intelligence. And we are asking, you know, traditional question, which is, how can we study this new technology? Can we use the same methodologies, the same designs, the same theories that we used in information system, or do we need to create something new? So the first question that I thought about when I had this question in my mind is to say, how can we study the impact of artificial intelligence on management today? And is it similar to the same what we did in the past when we analyzed the impact of information system at that time, the impact of information system on management? Because as you know, information system, management information system, the domain is new. It started in the 70s, early 70s, when some scholars started thinking about technology and how technology is impacting the way people are working. Someone is talking, or am I?
No, please continue.
Okay. So during the early 70s, a new domain arrived, which is the management information system. It had many names at the beginning. There was what they called identity crisis. It was so new, so it was like not very clear who we are. And they had like management information system, IT management, e-management, ICT management, plenty of names, plenty of subgroups working on the same topic, same logic, but with different names. And then till they stayed from 70s till 2003. In 2003, they started understanding clearly what is management information system. That it took like around 30 years. And they said, oh, management information system, I'm referring here to one of the most cited paper in this domain when we want to define what's information system, Isaac bin Bassat and Robert Smoot, 2003 in MIS Quarterly, when they said, it's about the artifact. It's about implementing an artifact, designing, implementing an artifact in a company, and then analyzing its usage, its implication. So now we know it took us 30 years to understand what's management information system. When we started management information system, we started with theories that we transposed. All these that you can see on the screen are the theories that we counted in information system. In the early 70s, 80s, and the 90s, most theories came from another domain. We call them traditional theories. They came from psychology, from sociology, from marketing, from finance. All those who came to this new domain, they came with their theories. But slowly, a new theory started to appear. A theory that was embedded, new theories started to appear embedded in the IS context. So new theories such as TAM, Technology Acceptance Model, that has by itself computed more than 10% of the research in IS during like two decades. Why? Because it was like management information system theory. So it was like, it took in consideration the identity of the topic that we're studying. So if we analyze all these theories that were created in MIS. They were born in MIS, Management Information System. We can see a very clear specificity. Now today, in 2021, 22, we know it very well. IS, Information System, there is a duality. When I talk about the duality, I refer to many names similar to duality. Most of IS theories are talking about this duality in different names. For example, socio-materiality of Orlikovsky, 2007, an organization study. Bostrom and Hennen, when they talk about socio-technical approach, 77. Orlikovsky in 1992, when she talked about duality of technology. So many theories will consider technology with this management information system, with this duality. From one side, you have the organization. From another side, you have technology. And the socio-materiality is this imbrication, this combination of both. And for example, in socio-technical approach, we can see it clearly that there, from one side, the technological approach, from another side, the social approach, and there is like a third approach, which is common, socio-technical, that to make the infusion of the two, let's say, components together. So that's something that we know today, we understand, and whenever we talk about IS, we take in consideration, like my colleague, Professor Marco Di Marco, one of the biggest names in information systems, said a few minutes ago, we cannot talk about the artifact alone. The artifact is embedded in an organization with an impact, with an interaction, users, acceptance. I really believe in all what he said, and this is what we call IS. So the question that I'm asking after hearing Professor Marco Di Marco is, can we transpose all these lessons to AI? Are we still in IS, or AI is a new domain, a new paradigm changing this? When we talk about artificial intelligence, what do we mean by artificial intelligence? We talk about these new systems that are not anymore programmed, but they can learn by themselves. They can create by themselves their model. And they try to answer problems in a clever way, in a way similar to human. They can use the rationality of human, and they can also understand human, sometimes limited rationality, like Herbert Simon said, and they can reproduce sometimes this rationality. So there are two big schools in AI today. We started AI with two big schools, and we still have these schools. We have what we call data-driven AI and human-centric AI. They have different names again. Data-driven AI can be considered as human-centric AI is considered symbolic AI, human AI symbiosis, human in the loop, many names, informed AI. So there are two big schools. The first one is data-driven, and these people are supporting an AI that can learn by itself based on data without human intervention, and it can make better results than human. And during years, they were not succeeding. Recently, surprisingly, with deep neural network, they started getting good results, especially in image recognition, in text recognition, in voice recognition. In some specific domains, let's say specific fields, they are getting good results. So data-driven AI considers that we can ask the machine to learn from data autonomously without any human feature engineering implication. The data will do automatic feature engineering, automatic modeling, automatic analysis, and will be able to make predictions, accurate predictions, and sometimes better than human. And they have some, I'm repeating myself, they have successfully beaten human in some games, and in games mainly, and in image recognition. The other school that I'm supporting, Europe is supporting in general, because mainly the data-driven AI is like an American school to give it a color. I don't like to give colors, but let's say that today investments, Facebook investments, and big investments are much more in data-driven logic than in human-centric. Europe is supporting only human-centric AI. They said it in 2018. They said in they said, if you want to present projects in AI, you need absolutely to design your AI as for human augmentation, augmenting human intelligence, human-centric AI, human in the loop, but not autonomous system that can replace a human. So human-centric AI is about designing AI while taking into consideration human ethics, human knowledge, human experience, human tacit knowledge, and putting human in the center of the process. So reducing all the negative effects that we can have one day if AI will become fully automated and autonomous and can consider human as a danger, because humans are a danger. This is the reality, and we know it. Once AI will become clever to understand how bad we are on our Earth, on our planet, on our ecosystem, it can consider us as a bacteria, as a danger that must be eliminated. So data-driven, we don't support this logic to keep AI developing itself, giving itself knowledge and acquire itself models that can become one day dangerous. In human-centric AI, human will stay in the loop, human will train, human will design, human will fix errors if there are any, and there are many errors, fix biases, there are many biases. When you deal with data, when you want to learn from data, we have a long experience with data analysis, we as human, and we know that biases must be reduced, and only human logic can, and human values can reduce these biases. Between the biases that are most cited recently, the discrimination biases that comes from data due to data fallacy and data fallacy, the fact that your samples or the data that you're using to train the model is by itself coming from real world. The real world is biased. The real world is discriminating women, for example, related to men in salary. I'm taking a simple example, but it also discriminates black vs white man. So that's real life. For example, if we take in the United States, if you have an AI that will analyze and give credit to people, it's demonstrated that it will give more chances to men, white men, much more than black men. It's demonstrated, it has been. So we need human implication to fix these biases in the sample by oversampling, for example, and by making modification. I don't go into details. Many methodologies can be used to fix these problems, these biases. And the most important, beyond biases, is to keep human values in the loop to guide the AI design and the AI training and implementation. So that's what we mean by informed AI. This is the school that we are launching, which is in the human-centric logic, but it proposes intervention of human expert in each step of the process in a specific way to reduce bias and to put human value to make responsible AI at the end. So, okay, we know now that AI has a specificity which is similar to IS, which is this duality between technical, let's say, knowledge coming from machine learning and these techniques that can become autonomous, and they have everything to become autonomous. But there is this duality with human, that they have values, that they, with years of experience, after 500 years of evolution, we have created knowledge in a clever way that can protect us, can protect our future. So we need to keep these values in the process. So if we think about the methodologies that we need to apply, or we can apply to analyze this AI trend, let's say, we can see today articles around us in different forms that are similar to what we saw in IS or in any science. We have qualitative analysis. Many articles are many AI articles are considered qualitative. Other are quantitative, modeling, and all the work of Samuel Fosuamba is quantitative with models, and they connect variables, they analyze variables using structural equation modeling, and they make like knowledge based on modeling. It can be mixed combination between qualitative case studies sometimes or action research and a quantitative to finish with the model. And there is something new that was really, that took its start mainly in IS, in Management Information System, and now it's becoming the heart of the big part of what's done in AI, which is design science. Design science is becoming important because AI is new. We have a lot of design effort to do, and design science is taking big part of it. So my own experience, to be honest, I will talk about my experience in these methodologies. I will, for example, I selected some of my small experience. I'm sorry to take only these experience. One is qualitative. We wanted to, in Europe, we wanted to introduce an AI to help farmers in their choices. That's a government, French government supported AI that we invested, that we designed and implemented to help French farmers to acquire economical intelligence, so they can take clever decisions based on the good understanding of the competition, the worldwide competition, so they can do clever investments, and yeah, they can optimize their efforts to the max. So that was the first one that you can see in IT and people. And what we used, and this is why I'm talking about this experience, what we used is, it was a canonical action research. So it wasn't a design. At that time, in 2018, we used a qualitative methodology that is called canonical action research, Davidson. This methodology is also a methodology that took action research that was famous in science, and they adapted to the IT context, to the IS context, by making canonical action research. So that was a good experience because we learned something from this methodology. I will go to this learning, and then I will come back to this slide, because we were talking about this learning. What we learned from this example, when we did the hidden facet of IT project, are revealed only after deployment, IT and people, 2018, we discovered that there are two kinds of theories that you need to bring with you when you do action research. One is focal theory, central theory, and one is instrumental. Because when you do action, when you do research, action research in IS, you have one organizational aim, and you need to use the technology as a tool to reach this aim. So there is technology, there is the instrument, and there is the objective, the management objective. So the duality that we saw previously in IS is well represented in this methodology. It fits 100%. This is why this methodology had a big success. For example, this paper, Davidson MIS Quarterly, has more than 1,000 citations. So it's very widely used in IS. I'm repeating myself to say that it takes into consideration the duality of technology by proposing two theories. One focal, which is management theory, and another one is instrumental, that will deal with how technology in an instrumental way will bring effect, will make an impact. So we learned this from canonical action research, from qualitative research. When we moved to quantitative research and started modeling, we learned that models can be so specific in their answer, but they are limited in the managerial implications. You need always, when you do a model and you, for example, you have a logistic problem, you modelize and you reach an optimized result, you're happy from your model. But then when you reach the managerial implication and you want to contextualize this in management, you will see that there will be like a little gap, because you need to extend like what you did to the max to fit a management question. But when we try to design science, when we try to design an artifact to solve a specific problem, and this we recently, the 4 or 5 papers that we published are all in design logic. I will say why, because first they came from practical experience. Most of what I published are coming from projects. So till now I'm managing like 6 or 7 projects. 2 are big, 2 are the main one. The first one is Shopper project. That is we want to implement AI and virtual reality to help archaeologists to analyze the past, because by understanding the past, we think that we can predict better the future. By understanding how people evolve with time, we can also see how we are evolving in the future. One of the problems of the past is that it was so far and no one lived as long to say what happened. So we cannot know what happened. We have some elements, and the AI must combine human knowledge, human experience, stories, and what we know from other research together, but especially also human tacit knowledge, this experience that is not well documented, not well formulated, to make good analysis of what happened. So in this project during from 2015, 16 till 2020, we were like analyzing how AI can take small indicators from small data sets to combine them, to converge them in a clever way, because usually when you have big data, it's easy to make like modeling. But when you have data with a lot of missing values, data that is error embedded, data with long time ago, that happened long time ago. So we needed to adapt the AI philosophy, design, and implementation to the specificity of having small quantity of data, a lot of missing data and errors, by replacing all these missing by human knowledge. So this is why we started immediately in this logic of human-centered AI, because human in the loop is important in this case, and informed AI was a must for us to be able to make clever prediction and good results. Then we transpose this to many other projects. Between these projects, the recent one, Viralexia, which is an Italian-French cooperation that received 98 on 100 on the European Commission, classified one of the best projects since the creation of this specific, let's say, domain. What we are trying to do again is to help dyslexic students, by asking them to do with virtual reality interaction, like a test or an exam, but we don't call them exam or test. We ask them to live an experience, to play a game, and then the AI will analyze their difficulties, and the AI will link these difficulties with methodologies and will propose games adapted, personalized to their difficulties, helping them to overcome their difficulties while gaming, while playing, using virtual reality, and helping them to move slowly to a better situation. So again, AI, but again, human, as you can see, augmenting human power, augmenting human knowledge, but not to replace them. Someone will say, yeah, you're replacing specialists. No, it's just a tool to help to become a medical assistant, to help these to help these the medical support by offering examples and training and tools, practical tools that can help these people to overcome with their hard work, to overcome their difficulties. So these two projects, like many other projects, helped us to understand that there is duality, there is a big duality, there is a human, there is techniques, and they must go together. And we transpose what we learned from canonical actually by saying if there is a duality, we need a double theory. We cannot analyze it in one theory. So from one side, we use design science. Do not suppose that we need really a theory, or if there is a need a theory, it will be one theory. So we took design science, which is Hefner and March introduction, when it came in 2004 in MIS Quarterly, saying, okay, well, if you want to make design science, they said you need to create a real artifact. So you need to take into consideration the environment to analyze the relevance, and then you need to develop this artifact as a solution, as an answer to a specific problem. So you need to apply knowledge to this design, and then you can get as an outcome efficient results based on this design. So we took this logic of design and we wanted to enrich it to make it more adapted to AI, and specifically to the duality of AI. So we introduced, because of the let's say this duality between human and technology, there are two components. We wanted to introduce two research questions. So usually when we do research in the past, it was you need to focus on one specific research question. So with AI, we felt, based on our small experience, 4 or 5 papers, recent papers, specifically designed for AI, one general management question and one specific AI question, technical question. You will ask me why it's not possible to keep one general question, because management questions are complex, they are big, while AI can help us today to answer very specific contextual answers. So there will be a mismatch, there will be a gap, if we say, if we keep large and the context. And this is why we are proposing that we contextualize the big managerial question with a very specific AI question. Can you hear me? Is the voice okay?
Yes, we can hear you.
Okay, thank you. Because I'm receiving message from my computer saying low connection. Okay, if the voice is okay, I will continue. So big managerial question and then very specific technological question. I will give you some examples from what we think is a good method. Then when we have theory, because we have this duality in the question, we need duality in the methodology, in theory. And again, the focal and the instrumental theory that we saw already in canonical action research is something that is accepted in AIs, in management information system, something done in action research. We transpose this duality in the theory, and we said that in our design research, we have 2 questions, 2 theories. One is focal, one is instrumental. So we have 1 question focal, 1 instrumental. We have 1 theory focal, 1 instrumental. The methodology, we think that the methodology must always be around designing an artifact or explaining how an artifact has been designed, but it's the same. Designing or explaining the design is similar. But we need absolutely, because it's science, we need absolutely to take into consideration human knowledge, and we need to add human knowledge. So it's not just a design to say it's solved, but we don't know how. CNN solved it. CNN, I mean, co-evolution neural network. It's not CNN, the American communication agency. So the neural network, the deep neural network, let's say, solve it is not a solution. It's not science. Science is explaining what happened, finding solutions, but explaining what happened. Explanation is important. So when we say human-centric, it means explainable AI, interpretative AI, responsible AI, ethical AI. All these AI are part of the human component when we have this imbrication. So we need to design a real artifact that includes human knowledge and that can add and augment human knowledge at the end. The result will be an imbrication between managerial results and technical results. So how did we, slides are not moving. Voilà. So some examples. That's one of our paper. The question was how to design a responsible and ethical way of collecting data and designing and using AI in healthcare. That's a managerial question. While when we think about, when we read the second question, what are the important factors increasing the survival rate of victims after an overdose incident, that's a very specific question in healthcare. So how do these factors contribute to overdose survival rate? That's something that AI can answer. We can make a design, specific design to help us improving the survival rate of victims of overdose. This is why the duality is here. So the third question is the duality. How can we convert complex AI into more now I inverse the question. That is the big question, managerial question. How can we convert complex AI model into more transparent and explainable solutions? That's the management question. The technical question, what are the important factors increasing the survival rate of victims of overdose? And the imbrication, how can we design a responsible and ethical AI to collect, to save people from overdose? So these are the questions that we start from a managerial question, and then we finish with a very specific instrumental question. How do we, once we do this, then we need to use a theory, two theories. Again, examples from what we did. The first theory is a management theory. It's a focal theory, a center theory. For example, when we want to talk about responsible AI, we went analyzing management theory, and we discovered that in management theory, we have ethics. So there's a theory of ethics. And in theory of ethics, there are principles. So we take these principles from theory of ethics, principle of transparency, of justice, of non-maleficence, accountability, and privacy. And then we combine this theory with an instrumental theory. In the case of emergency, we have instrumental theories related to emergencies, such as PTOC theory, that talks about mitigation, preparedness, response, and recovery. And we combine these two theories to design an AI adapted to the specific context of overdose that we are studying. So we combined one focal theory with one instrumental, focusing mainly on the specificity of overdose and the emergency situation coming from this overdose. On the methodology, we started with designing specific AI that will help us answering the instrumental question, but increasing also, implicating also, and adding also human knowledge to get also focal knowledge at the end. So for example, when we designed the emergency AI tool, we took into consideration the human principles, the human values, because we are dealing with human. Technology AI artifact, the AI designed artifact, was obliged to learn human values, the principles that I said a few seconds ago. And we were always verifying, we as a human, that we gave him the right input, and the system and the AI was able to respect these values. We test him like we test him on, like you test on any training, we test him on the values also. So in our design, as you can see here, these are two different designs, but they are similar in the fact that in all components, all process from data preparing to training the model, to selecting the algorithm, to training the model, to testing the model, and to implementing the model, or not the model, but it can be also the complex design. It can be also a mix of many models that we call, what do we call it? Ensemble models, means a group of models designed in a specific way. They work together. For example, here, you can see here 1 model, 2, 3, 4, and 5. 1 model to analyze and prepare data to make like CPA, principal component analysis, combined with 3 models, neural network, SVM, and random forest, and shape to explain. You see this combination, this trio. It's a design, it's an ensemble that at each step was designed and trained not only on data related to overdose, but also on rules and logic and values that human were implicating and expert implicating. We also introduced expert knowledge in some places to fix some errors, reduce the gaps. At the end, we get what? We get a result, which is a combination of a technical result, because we will have, like any AI research, we will have like a matrix and with design with results, and we need the confusion matrix that we need to validate. We validate the training, we test, and we check that it's valuable and the results are of big value, as you can see here on your left. But we also have results that are managerial, that are included in a focal logic, which is to say that this design has respected privacy, because he didn't take, for example, names or specificities of, he applied the rules of RGPD in France or in Europe. Justice, the discrimination didn't happen. So he didn't, for example, discriminate men or women, or discriminate black or white, because we have checked all this and we have followed all the process from data collection to the data cleaning to the training, selection, and till the end. And on the user, the same in all part, data collection, on the design, and on usage, the system was respecting these values, and we contributed in this way to answer not only the instrumental question, but also the managerial focal question. As a conclusion, ladies and gentlemen, and lessons that we learned, AI is today, there are similarities, as you can see from my speech. I imagine that there are big similarities between what we saw in information system, because it was at that time technology that can replace a human or complement a human with a human. So there is this duality which is similar to IS. But here, what is plus related to IS, we were talking in the IS about data and information. Here we'll talk about knowledge. So you saw me always using the word knowledge, which is a higher level of abstraction than technology, than information system. Information system will be efficient whenever it's about information. But when it deals with knowledge, with human knowledge, when we need to add more values, more tacit knowledge and things that we did not succeed in doing in IS in the past, AI can be the solution, is the solution. From all the four examples that I presented here, and the two other that we're working on that are not published yet, we see that the tacit knowledge is the heart of the added value of AI compared to information system. So there is also, so from one hand, there is a similarity with IS, but there is also probably a new heart of something that can be developed with time. We are only new in AI. It took us 30 years to discover what is the heart of information system research. So probably it will take us some time to understand what's this, how we can call this capacity of taking into consideration human tacit knowledge and converge all these tacit knowledge of people together in one AI that can become expert, but as expert or as the number of experts who participated at training him and teaching him rules and logic beyond what he discovered from data, of course. So it's a double competency that we have. So the specificity also is related to this collaboration. AI is completely different in IS and something. It cannot work if there is no full understanding between and collaboration between data scientists, computer scientists, data scientists and engineer, computer science specialists, experts, and researchers in management and business. In all our teams, we were like around 4, and reviewers were saying, oh, why are you 4 or 5? Because we are a multidisciplinary team. AI is multidisciplinary by nature, by definition. And to answer managerial questions, you need absolutely multidisciplinary people. So an example, when we decided to work on plant science, we worked with a team specialized in plant science. When we worked on health, team specialized in health care. Dyslexic, we have 3 teams specialized in each one. Each team is specialized in kind of dyslexic. So there is this these knowledge that are structured, and they can be taken into consideration easily. But what's good and the plus that we need absolutely to underline one day, and we're working on it, is to see how this experience and tacit knowledge can be also put in together to succeed our mission. So this combination of these people is very powerful, because people stay a long period of time learning one discipline. We cannot have one person with all these disciplines. This collaboration can make AI multidisciplinary and can empower our knowledge, augment our knowledge, because it will add people knowledge that are complementary by definition, but we couldn't put them together because most of us are protecting our knowledge, and we are becoming so specialized in our domain that we are very, very specialized in small things. AI will be combining all this and augmenting all this. And this is something that you can start seeing in our results. But there are some difficulties because people are in the heart of the system, and we are retransposing people limitations, which is lack of communication, sometimes different words, it's time consuming, and it requests a lot of work to prepare the project and prepare the field to an AI. So because these people are coming from different backgrounds, they have semantically different words, and there is a big work of putting all these words together to put one common language, one common language to be able to work efficiently in a project like this. I have attached here a list of references related to the topic and to the points that I was underlying. The most important are here, Ben Bassat 2003, when they defined MIS domain, but that's very known. Orlikovsky with the duality and socio-materiality, which is it can still today be part of what we are saying, but we need to add a big plus, but we don't know what yet. So there is something socio-materiality plus that we will discover with time, I think. Not me, I mean we researchers in AI. So I'm using we, but please understand that I was like thinking that we as scientists in general, in information system and AI precisely. And other articles that we collaborated on to make our small contribution to science in this domain. Thank you very much. I don't know if we have questions or people are still there. Are you still there, or they probably left, I think.
Thank you, Antoine. It was brilliant and very interesting. Dear participants, if you have questions, please don't hesitate. You are welcome.